Hi everyone, welcome to another revision lecture where we'll be discussing the chapters alkenes, alkynes, group 2 elements and mole concept. We'll be discussing the questions of the DPP sheet which has been put in the Telegram channel. So let's get started with question number 1. This is from organic chemistry, alkenes and alkynes portion. So let's start with question number 1. Which of the following compounds on elimination gives alkenes? So we have studied the preparation of alkenes, and there we have studied that we can prepare it from alkyl halides by treating with alcoholic KOH, and when we are treating it with alcoholic KOH we have studied that it will get converted to alkene, and this is an example for elimination reaction. Now if I talk about the conversion of alcohol to alkene, there we are using concentrated H2SO4, and again the mechanism is removal of OH from here and H from here, so it is again elimination. The third one is vicinal dihalide. So vicinal dihalide is treated with zinc in the presence of methanol. So when we are treating it with zinc in the presence of methanol, again we are getting CH2 double bond CH2. So this is again a sort of elimination where the two bromine atoms are replaced. So all of these are following elimination method and they are giving us alkene. So the answer for question number 1 is option number D. Question number 2, we have an alkyne and that is treated with hydrogen. It is treated in the presence of palladium in the presence of quinoline. This is known as Lindlar's catalyst. And sodium in the presence of liquid NH3 is known as Birch reduction. So always remember that Lindlar's catalyst will help in the formation of cis isomer and Birch reduction will help in the formation of trans isomer. Now among these two, which one is more stable? It is trans. So we have to understand that heat of hydrogenation is inversely proportional to stability. So trans is more stable, so it will have minimum heat of hydrogenation. So the question is heat of hydrogenation is minimum in, and the answer should be transform, and transform is B. So the answer is option number B. Let's move on to the third question. We have this particular compound treated with alcoholic KOH. So obviously we can get different variety of alkenes. So this is possible, and here we are doing ring expansion. Followed by elimination, and there also we will be getting an alkene. But here we have alcoholic KOH, so there is no possibility of getting an alkane. This is not possible, and it is asked which is the not possible product. So the answer is option number D. Question number 4. An alkene A on reaction with ozone and zinc in the presence of H2O, that means it is reductive ozonolysis. The reaction is reductive ozonolysis, and we are given that A is undergoing reductive ozonolysis and we are getting propanone, that is CH3COCH3, and ethanol, that is CH3CHO. So first of all we have to find A, and after that it is given that it is treated with HCl. A on addition of HCl will give us B. So they are asking us about the structure of B. So let's start with ozonolysis. So we are getting the product as CH3COCH3. This is the first product, and the second product is CH3CHO. So this we can write it like this. Now we are going to remove the oxygen atom from here and we are going to join these two with a double bond. So this is the alkene that we are getting. This is A. Now we have to add HCl. So there is no peroxide used over here, so it is Markovnikov's addition. Now in Markovnikov's addition, this side we can see that it is having more number of hydrogen, so to that side we will add hydrogen, and to the side which is having lesser number of hydrogen, that side we will add the substituent. So we have to remove the double bond also. So this is the product that we are getting. Now let us match this with our options. Now if I am matching it with our options, we can see that it is option number C. Question number 5. We have this particular reaction and we have to say what is the compound A. So if we have CH3CH double bond CH single bond CH2 single bond CH3, first of all we have to take HI, and HI on dissociation will give us H plus and I minus. This H plus should be added, so that can be added either over here. If I am adding it over here, I am getting a carbocation, that is this, and here we can see that this is the alpha carbon, this is also alpha carbon. So if I'm counting the number of alpha hydrogens, we can say 1, 2, 3 and 4. Total 4 alpha hydrogens are formed in the structure A. Now another possibility is, instead of adding the hydrogen here, I can add the hydrogen over here. In that particular case, this is going to be my alpha hydrogen, so this is going to be my positive charge, and this is my alpha carbon, this is going to be my alpha carbon here, and this also can be my alpha carbon. So if I count the number of alpha hydrogen, it is going to be 3 plus 1 4 plus 1 5. So since the number of alpha hydrogen is more over here in the second case, so this is the more stable carbocation. So to the more stable carbocation, we have to add the iodine. So the answer should be this: CH3, CHI, CH2, CH2, CH3, and that is present in option number B. So once again, we have to understand that stability of carbocation we have to consider, and stability of carbocation depends on number of alpha hydrogen. Why are we interested in number of alpha hydrogen? Because greater the number of alpha hydrogen, greater will be the number of hyperconjugative structure, and greater the number of hyperconjugative structures, greater will be the stability. So this is the important concept, and once we get the stable carbocation, then we can introduce the next part, that is the I minus. So that we have introduced over here. So this is how we have done this. First of all, we have to generate the carbocation, and we have to look for its stability in terms of hyperconjugative structures, and after that we have to add the I minus. Question number 6, we have this compound, that is propylene, which is treated with red hot iron tube. So that is going to give us mesitylene. So this is an important reaction. It was asked in last year's NEET question also. They have asked what is the number of sigma and pi bonds in this compound. So that type of questions can also be expected. So answer is option number C. If we had ethylene over here, then the answer could have been benzene. So that is also important. Moving on to the next question. It's a little tricky question. It's a question related to KMNO4. So clearly we can see that this is concentrated, hot and acidic KMNO4. So whenever we have concentrated, hot and acidic KMNO4, we have to use the trick that we studied in the lecture. So if you don't know the trick to do that, then you have to watch the lecture of alkenes and alkynes. So here we can see that we have a group like this. This is the group that we are having. So when such a group is present, that will be converted into double bond O. Whenever we have double bond CH2 group, that is converted into double bond O by the presence of KMNO4. So here the option should be option number A. Let us now talk about question number 8. Addition. Before that, we have here B and C. I will tell that also. B is turning lime water milky. So what is the gas? The gas that is liberated is CO2. And C is turning the COSO4 crystal, that is a green crystal, to blue color. So C should be water. So if someone is asking what is B and C, so this is the answer. Let us now move on to question number 8. Addition of HBr to 2-methyl 1-propene in the presence of hydrogen peroxide. So it is anti-Markovnikov addition. So first let us make the structure of the compound. It is propene, 1-propene, and to this we have to add CH3 group. So this is CH3 and this is CH2. Now we have to add HBr. So it is in accordance to anti-Markovnikov addition, and since it is in anti-Markovnikov addition, the hydrogen will come to this side and bromine will come to this side, and this double bond is broken. So what will be the answer? It will be 1-bromo 2-methyl propane, and the answer is option number D. Let us now talk about question number 9. So these compounds are very important. Their hydrolysis is asked. Mg2CO3 on hydrolysis will give propine. So this we have to remember. And Al4C3, that will give us methane. CaC2 will give ethane. So these three are important. Even if you don't study this is not that much important, but these three hydrolysis are very important. This will give propine, this will give methane, and CaC2 will give C2H2, that is ethane. Now let us talk about question number 10. So this question we have discussed yesterday also, butane 1 and butane 2. So butane 1 is a terminal alkyne and this is a non-terminal alkyne. So terminal and non-terminal alkyne can be distinguished by Tollens test. This will give a positive result and this won't react. So the answer should be option number B. So with this we completed the organic section. Now let's move on to the inorganic section. Which of the following have the largest atomic size? So for this question we have to use a trick. So why we have to study a trick is because we have group 1 elements and also group 2 elements. So let us study the trick for understanding the or learning the size, atomic size comparison of group 1 and group 2 together. So first of all, write down the elements like this: lithium, sodium, potassium, rubidium, cesium, this is group 1, and beryllium, magnesium, calcium, strontium, barium, this is group 2. Now what am I going to do is I am going to start from here. I am going to make an S like this, and I'm going to make an N like this. Now I have to join these two. So if I write the order, beryllium will have the least size, then it will be lithium. Next I have to go to this magnesium, and then comes sodium, then comes calcium, then comes strontium, barium, and then comes potassium, then comes rubidium, and then comes cesium. So highest size is for cesium. So this is the trick for learning the size. So as per this question we have sodium, potassium, calcium, and barium. So let us mark these elements over here: sodium, potassium, calcium, and barium. So if I look at these elements, we can see that potassium has the maximum size. So the answer for this question is option number B. Question number 12. Among CaH2, BeH2, and BaH2, which one is the correct order of ionic character? So ionic character is predicted by Fajan's rule. So if we look at the Fajan's rule, the anion is same, so we have to consider the cation. So if I consider the cation, it is Ba2 plus, Ca2 plus, and Be2 plus. Smaller the size of cation, more is the covalent character, so less is the ionic character. They are asking us about the ionic character, so this will have the least ionic character, followed by calcium, and then comes barium. So this is the decreasing order. Maximum ionic character should be for barium, then should be calcium, and then should be beryllium. So if you look at the first option, so one second, let me just write it once again. We have Be2 plus, Ca2 plus, and Ba2 plus. So if I consider the size of these cations, we can see that this is having the least size. So this is the size order. So the covalent character is directly proportional to size of, inversely proportional to the size of cations. So we can say that Be2 plus is most covalent, then comes Ca2 plus, and then comes Ba2 plus. This is the covalent character. So the ionic character will be the opposite of that. So Ba2 plus will be the most ionic, followed by Ca2 plus, followed by Be2 plus. So here Be should come as the minimum. I think we don't have an option like that here. So this one is the correct option, but we have to change the sign. So let us make arrangement in the sign. BaH2 is the highest ionic, then comes CaH2, then comes BeH2. Now it becomes the answer. Answer number 1 is correct, but the sign was different. So let us now talk about the next question. Question number 13, which states chemical formula of plaster of Paris is. Now it's a very direct question. Plaster of Paris, which is POP, has a formula of CaSO4 dot half H2O, and this one is gypsum. So these two are important. On losing some amount of water, it will form gypsum. Next, suspension of slaked lime in water is called as. Suspension of slaked lime in water is called as milk of lime. This is a NEET exam question, previous NEET question, so this is important. Next one is, which of the following shows the lowest melting point? Now in the last lecture also I have told you that whenever we have Fajan's rule, this Fajan's rule is really helpful in many cases. It is helpful in predicting ionic character. It is helpful in predicting the covalent character, solubility, melting point, and boiling point. Melting point, boiling point, and ionic character have the same order. So first of all we have to write the covalent character order. That's what we can write easily, because here we have anions different and cations same. So if I arrange the anions according to their size, we can say F minus, that is the least, then come Cl minus, then come Br minus, and then come I minus. So more the size of anion, more will be the covalent character. So this has the maximum covalent character. Maximum covalent character means minimum ionic character, and minimum ionic character means minimum melting point. So minimum melting point is for CaI2. So the answer is option number D. Question number 16. Which of the following is present as an active ingredient in bleaching powder? It is CaOCl. CaOCl twice. This one is the answer, because OCl minus is responsible for the bleaching action. So this is the answer. Question number. So this is the question. Question number 17. Thermal stability of group 2 carbonates follows the order. So thermal stability increases in the case of carbonates, and in the case of hydrides it will decreases. So here this is the answer. Question number 18. Hydrated ionic size is highest for. Hydrated ionic size, I told you yesterday that it is inverse of ionic size. So Be2 plus is having the smallest ionic size, so it will have the maximum hydrated ionic size. So the answer is option number A. Which of these will react with HCl and NaOH both? So since something have to react with an acid as well as a base, so it should be an amphoteric substance. And which among the following is amphoteric? It is beryllium. That is why beryllium stands as an exception. It is not considered as an alkaline earth metal. It is not an alkaline earth metal because it is producing amphoteric hydroxides. Moving on to the last question. Which of the following ions is responsible for muscle contraction? It is Ca2 plus. I think you know this from sliding filament theory. In sliding filament theory, we are studying about the role of calcium. So it is calcium is the answer. Let us move on to question number 21. This is from mole concept, and little bit conceptual questions are coming in this section. An element X forms 5 stable oxides with oxygen of the formula X2O, XO, X2O3, X2O4 and X2O5. We have to find what law is obeyed. So this X2O, we can write it as X2O itself. XO, I am going to write it as X2O2. The other one is X2O3. Next is X2O4, and last one is X2O5. So I am going to keep the mass of X as a constant and mass of oxygen is variable. So their ratio is going to be in the ratio 1:2:4:5, and that is a simple whole number ratio. So this is obeying the law of multiple proportion. Option number C is the correct answer. Let us move on to the next question. Suppose the elements X and Y. This is a very interesting and an easy question. It was asked in NEET 2016. Suppose the elements X and Y combines to form two compounds XY2 and X3Y2. Okay. When 0.1 mole of XY2 weighs 10 gram, 0.1 mole of XY2 is going to weigh 10 gram. So what is the mole of 1 mole? What is the weight of 1 mole? Weight of 1 mole is going to be 100 gram. That is the molar mass of the salt. Now how do we write the molar mass of a salt? Molar mass of a salt is X plus 2Y. That is equal to 100. So we got our first equation. X plus 2Y is equal to 100. Now second part is stating that 0.05 mole of X3Y2 weighs 9 gram. So 0.05 mole X3Y2 उसका वेट है 9 ग्राम. सो 1 मोल X3Y2 उसका वेट कितना आएगा? X ग्राम. Upon cross multiplication we will get 0.05x is equal to 9. So x is equal to 9 divided by 5 into 10 raised to minus 2. So this is going up. So it is 900 divided by 5, and this will comes out to be 20 into 9, that is 180. So that is, let us put this as P gram, or else we'll have a confusion here. So let us put P here. P is the mass of X3Y2, molar mass of X3Y2, that is coming out to be 180 gram. Now X3Y2 का mass कैसे लिखेंगे हम? That is 3x plus 2y, और वो 3x plus 2y आएगा 180. that is equation number 2. हमारा पहला equation था x plus 2y is equal to 100. So x plus 2y is equal to 100. This was equation number 1. जब मैं 2 minus 1 करेगा तो 2x is equal to 80, इसलिए x कितना आएगा 40 आएगा. सो x का वैल्यू है 40 और y का वैल्यू कितना आएगा ये हम पर डाल देना चाहिए. तो y का वैल्यू आएगा 60/2, that is 30. So 40 and 30 is the answer. Option number A is the answer. Question number 23. What is the mass of 0.5 moles of ozone molecule? So here we have to study the basic formulas of mole. We have number of moles is equal to given mass by molar mass. So we have to find this. M is equal to number of moles into molar mass. Now what is the molar mass of ozone? Molar mass of ozone is 48 because 16 into 3, 48. That into number of moles is 0.5, so it is coming out to be 24 gram. उसका आंसर होगा C. Question number 24. A mixture of gases contains hydrogen and oxygen gases in the ratio of 1:4. What is the molar ratio of the two gases in the mixture? So in this question, we have to use the formula again. Given mass by molar mass is equal to number of moles. So if I find the ratio of NH2 by NO2, that is equal to M of given mass of hydrogen by given mass of oxygen into molar mass of oxygen by molar mass of hydrogen. So I have to substitute here NH2 by NO2. I think it is given. No, this we have to find. This is given as 1/4. So this I will substitute as 1/4. This is 32 and this is 2. So this upon cancellation becomes 16 and this will give us 4:1. So answer is option number C. So they have asked what is the ratio of H2 is to O2. So it is 4:1. Next, let us talk about question number 25. So here, this is very easy question. We have 6.02 into 10 raised to 20 molecules of urea, which is present in 100 ml of its solution. What is the concentration? Now, concentration can be expressed in terms of molarity. So, molarity is equal to number of moles by volume of solution in liters. But since it is given in milliliters, we have to divide this by 1000, so that 1000 will come up. So this is the formula. So what is the number of moles? We know number of molecules is equal to number of moles into Avogadro's number. So we can say number of moles is equal to number of molecules by Avogadro's number. So here it is 6.02 into 10 raised to 20 divided by 6.02 into 10 raised to 23. So this is 10 raised to minus 3. So this will comes out to be 1 divided by 100 because its volume is given to be 100. So it is 10 raised to minus 2 molar, or we can say 0.01 molar. Option number A is the answer. Next, this is the next question. I think it is question number 26. It is question number 26. So this is a question related to empirical formula. An organic compound containing carbon, hydrogen and nitrogen gave the following analysis. C is equal to 40%. So we have to write the percentages down. Now we know the atomic mass of each of these elements. So if I divide this percentage, that is the given mass. We are assuming that the total mass is 100 gram. So this is the given mass of carbon. So we can calculate the moles by using the ratio given mass by molar mass. So we can find the number of moles of each case. Here we can see that this 3.33 is the smallest value among all. So we have to divide each of these with 3.33. So we will get the simplest ratio. And we have to simply arrange this formula according to this ratio. So we will be getting CH4N as the empirical formula. It's a very simple process. Now, how can we calculate the molecular formula? Molecular formula, if they are asking us to calculate, then the trick is, or the method is, we have to find empirical formula mass first and molecular formula mass will be given. Molecular formula mass is the actual molar mass of the compound. So this will be given to us. This we have to calculate. Sometimes instead of this they will give us vapor density. So remember, vapor density is equal to 2 into molecular mass. So vapor density by 2 is going to be the molecular mass. So from that we can calculate it. So if this is known and this is known, we can find the N factor. N factor is equal to molecular formula mass upon empirical formula mass. This is the formula for calculation of N factor. So once we get the N factor, we have to use the concept molecular formula is equal to n factor into empirical formula. Molecular formula is equal to n factor into empirical formula. So by that way we can calculate the molecular formula. So this is the method of solving this type of questions, and this is important question also. This is a NEET exam question. This type of questions are asked recently also. Question number 27. 2.5 liter of 1 molar NaOH solution is mixed with 3 liter of 0.5 molar NaOH solution. Then find out the molarity of the resultant solution. We have to find the resultant molarity. So it is the same solutions. Same solution is mixed. So we can use the formula M1V1 plus M2V2 is equal to M3V3. And what is V3? V3 is the sum of these two volumes. So it is V1 plus V2. So if I am substituting the values here, I will be getting 2.5 into 1 plus 3 into 0.5 is equal to M3 I don't know into this one I have to add, so it is 1.5. So this upon simplification will come out to be 0.7 molar, 0.73 molar. So the answer is option number C. Next is question number 28. Question number 28. This is a very important and a conceptual question. So let us do this with every options by analyzing every option, because anything can come in the exam. In the reaction 4NH3 plus 5O2 giving 4NO plus 6H2O, when 1 mole of ammonia and 1 mole of oxygen are made to react to completion, then which of the following statement is correct? That is what is asked. So first of all, we can see the equation once again. 4NH3 plus 5O2 gives 4NO plus 6H2O. So I will write it here. 4NH3 plus 5O2 gives 4NO plus 6H2O. So as per the stoichiometry, we can say that 4 moles of ammonia will react with 5 moles of oxygen to form 4 moles of NO and 4 moles of H2O. This is what we can understand from the stoichiometry. So what is given is that we are given 1 mole of ammonia and 1 mole of oxygen. So we are going to take 1 mole of ammonia. So as per the stoichiometry, we want 5 by 4 mole of oxygen. As per the stoichiometry, we need 5 by 4 mole of oxygen. But here we got only 1 mole, and obviously this 5 by 4 will be greater than 1. So the value that we need is greater than the value that we have. That means oxygen is present as a limiting reagent. So oxygen is acting as a limiting reagent. So all of the oxygen will be consumed. So let's check whether we have that option. Yes, option number 1 says all the oxygen will be consumed because it is the limiting reagent. Now, as per the question, we can say 4 mole of NH3 reacts with 5 mole of oxygen to form 4 moles of NO. Now, we have to find what is the number of moles of NO that is formed. Let's check whether it is 1 or not. So we have this as the limiting reagent, so everything we will be taking with respect to this only. So 5 mole of oxygen will give 4 mole of NO. So here we have 5 by 4 mole, so that will give us X mole of NO. So let us find the value of X. X is equal to 4 into 5 by 4 divided by 5. So that will come out to be 1 mole, right? Sorry, there is some mistake here. Let's do it once again. We have 5 moles of oxygen giving us 4 moles of NO. So here we have only 1 mole of oxygen, right? We have only 1 mole of oxygen. So it will react to give X moles of NO. So what is the value of X? X is 4 by 5 and this is coming out to be 0.8. Yes, it's not 5 by 4 moles of oxygen, it is 1 mole given in the question. So it should be 0.8 mole. So that is why option number 2 is incorrect. Now let us do option number 3. If I take it in the same account, 5 moles of oxygen will give 6 moles of water. So 1 mole of oxygen will give 6 by 5 moles of water. and this 6 by 5 will be 1 point something. It is not 1 mole, it is greater than 1 mole, so that is also wrong. All of the ammonia will not be consumed. Why it will not be consumed? Because it is the excess reagent. Some amount of ammonia will still exist even after the reaction is completed because it is an excess reagent. Next, question number 29. Boron has two isotopes, this one and this one. What is the atomic mass? So here we can use the formula of average mass. Average mass is equal to m1x1 plus m2x2 by m1 plus m2. So when I substitute the values, 10 into 19 plus 11 into 81 divided by 81 plus 19, so it will comes out to be 10.81. Answers option number A. We have the last question here. This is a very important question also. 1 gram of magnesium is burnt with 0.56 gram of oxygen in a closed vessel. Which reactant is left in excess and by how much? So as per this question, we can see that 1 gram of magnesium is burnt. So let us write the equation first. Mg plus O2 gives MgO. If I balance the equation, I have to put 2 here and 2 here. So which reagent is left in excess is asked. So this is 48 gram, that is reacting with 32 gram. In the question it is given that it is 1 gram. So how many grams of oxygen is required? We have to just cross multiply. So x is equal to 32 upon 48. Sorry, this is 32 grams. So 32 upon 48. So this is 16 upon 24, or it is 2 upon 3. It is 2 upon 3. So it should be 0.66 gram. But we have only 0.56 gram. So we are not getting the same or greater than that is given as per the theoretical value. That means it is acting as a limiting reagent. Oxygen here also is going to act as a limiting reagent. So we found limiting reagent, and once we get the limiting reagent, the other one is going to be the excess reagent. So we can eliminate two options because they have asked for excess reagent. So now let us see what is the amount of magnesium that is left. So we are given 0.56 gram of oxygen. For 48 gram we need 32 gram of oxygen. So for this much, for the complete reaction of this 0.56 gram, we need x gram of magnesium. We have to find this x, and after that we have to subtract that x from 1, and when we are doing that we will get option number A as the answer. Once again, we need only this much because we have only this much amount of oxygen. So we have to find what is the mass of magnesium that will react with this much mass of oxygen. We will find it out, and we have to find how much it is left in excess. For that we have to subtract it from the mass that is taken, that is from 1 gram. So 1 minus this thing, 1 minus x, that is going to give us 0.16 gram. So the answer should be option number A. So with this we are concluding the discussion of DPP 2. But before we conclude, let me tell you some mistake that were reported in yesterday's DPP sheet. First mistake was with respect to this question, second question of organic chemistry. Here option B was supposed to be malic acid. Option B should be malic acid because malic acid and fumaric acid both are dienoic acid, and they won't give alkene as a product. Only succinic acid will give us alkene. That was the first mistake. Option B should have been malic acid, not malonic acid. And another mistake was related to question number 6, where both the option 1 and 2, A and B, are correct because 5h by 2 pi and 2.5h by pi both are same. So both these options are correct options. And one more mistake that was found was in question number 8. If the radius of the mth orbit of lithium 2 plus was asked, so the formula was Rn is equal to 52.9 n square divided by Z. So here we have to substitute the values. 52.9 n square by 3 is equal to 70.53. So n square will comes out to be approximately 4. So n is equal to 2. Answer was option number A. I told it as B, that is wrong. It is option number A. So these were the mistakes that were reported in yesterday's question paper. And please note that mass of neutron can be 1.00867 in terms of atomic mass unit. We can express it either in terms of U and in terms of kilogram as well. So here I have written it in terms of U. So that is also correct. So that's all about today's discussion. I hope you did the test well. So in the next lecture we will be discussing next 3 chapters, and the chapters that we are going to discuss is number 1 is benzene from organic parts, group 13 elements from inorganic parts, and states of matter from physical chemistry. So see you again in the next lecture. Till then, goodbye and happy learning.